This is another example of how to use makeCorTemplate and CorMatch from the MonitR package in R to make a acoustic template that you use to try to match species vocalizations in a survey recording. And I'm going to work with the species CapCon, which is the Bonaparte's nightjar. And so I'm going to go ahead and share the screen. Okay, so first load these packages, then set your working directory to the folder where all of your survey files are. And then this step you can skip for now. So to make the template, you use the function makeCorTemplate, and it creates a template object. And I'm working with CapCon, so I'm going to call my first template CapCon temp1. The first thing you fill out is the file path to the survey, or to the source file that you want to use to derive the template from. And for me, I have that in template source files. And it's this wave recording that has the vocalizations in it I want to use for the template. So there's the file path to that. And then I know that the vocalization occurs in that recording between 15 seconds and 45 seconds. So for the time limit, I specify 15 seconds to 45 seconds. Frequency limit, I know that it's occurring between 0 kilohertz and 0.8 kilohertz. So that's why I set that frequency limit, which you would want to change if your species is higher. It helps to restrict the time and the frequency so you can see it better when you go to make your selection. The score cutoff I'm setting at 0.3 because that sort of generally works to start out. And the score cutoff represents the point at which it calls something a detection or not. And so the higher your score cutoff, the fewer detections you'll have, because your detections will have to match the template more accurately. And it's from 0 to 1. So if your score cutoff's 0.1, it's going to call a lot more things detections than if you had a higher score cutoff. And then, so it's a kind of ratio. You can read more about it in here. Oops. Anyway, I use this window length and it works well for me. Oh, and in the name and comment fields, I keep these matching the name of the template. So CapCon1, CapCon1, which will be relevant later. And then once you run this, it plots your, so here is that code, and then it comes up with a plot that is this little clip that you've specified. So it's 15 seconds to 45 seconds from 0 kilohertz to 0.8 kilohertz. And then these are the vocalizations, these red marks, which I know because I've already looked at this file before, but it does help if you look at your template source file ahead of time and know roughly what's there, so you know you're drawing from the area that has the species in it. Otherwise, you're trying to search this kind of shitty spectrogram view for something over, you know, you can imagine if this was 3 minutes long, it might be hard to see what's going on. And so then it asks you to make a rectangular selection, which you do specify here, and I haven't changed this to anything else, but rectangle works for me. And it says to select the upper left corner of the rectangle with a left click. So in this case, I would click up here and then select the lower right corner with a left click. And so you're setting the bounds of the rectangular selection of the acoustic file. And then when you're done, you hit escape. So in this case, I finished my selection. It's this chunk that I want to use. And then I made 2 other templates. So I took a few samples from this file because I'm curious if they'll be redundant or if it'll help it match more accurately. And then I had these three templates that I wanted to make into kind of a batch. So first I write them into the template directory that I've specified, which is using the function WriteCoreTemplates. And the place that I want these to go is this folder templates R, and then the subfolder capcon for this species. So using WriteCoreTemplates, you first list the template object that you want to write into the directory, and then the file path to that. And when you run this, it produces a CT file. And so that's what these three files are. Then I want these to be represented by one template object just to make it more streamlined while matching it later with another survey file. And so in this case, if you had 4 different species that you were trying to do at once and they each had multiple templates, it would make it a lot easier to combine those into one object. And in this case, for me, it's just this one species, so I'm going to call it CapConTemps to represent these 3. And using the function combine core templates, which you just list the template objects that you want to combine. So it's now calling these 3 as a group CapConTemps. And then read core template. So it's reading this object from this directory, which is here. And now I want to try to match these in a survey file. So the function is CorMatch, and it creates a list object that has the detections and the matches with your template. So first you put the file path to the file that you want to survey, your survey file. And in this case, I want to search in AudioMoth Binio this device first, A0C. And I want to first start with the very first survey recording, which is this on the 16th at 5:30. So I have that file path here, AudioMoth Binio, the device folder, and then the name of the WAV file that I want to search. And then you do comma, and then your template object that you want to try to match within your survey file. And then I want to see the results of this. So find peaks will show you so it's going to help you look at the results of this matching process. And I've been working with other files, so I've just been going in numerical order here. So I'll start out this at 187, just continuing where I left off. And this is producing another list object. So you can call this whatever you want that works for you, but I just make sure I keep it organized, because if I'm doing this multiple times, then I might write over a past list object. So I've just been doing it in numerical order. So the functions find peaks, and then I want to find the peaks of this. I guess I'll just start from 0 since we're on a new species. So, or maybe I should redo this actually. 187. Okay, so I'll go ahead and run this. So this is going to take a minute here, but you can see it's working. I'm running CorMatch right now. So CorMatch is done. Oh, why did it still search that? Anyway, so you'll see it working, and then it'll start to go through each template that's in your group. So there's the first one. second one, third, and this one I tried to get rid of, but it still searched for it, so whatever. Anyway, so then when it's done, I get this error message because my file name and my file info don't match the format that R likes to use for deriving the date and time information. And it does end up becoming a problem in that the CSV file that you get that shows all of the matches within this file doesn't show the right date and time. But I have a workaround for that where I just name the CSV file with the correct date and time. But there, so you can mess with this, the time source parameter in CorMatch. But I'm able to just kind of continue going. Someone else may have a better way of dealing with this, but I've just been kind of hacked, like continuing with it, and it's fine. So now I've got, it's made matches, and now I want to look at the detections that it's come up with. So I'm going to use find peaks to see what, start looking at some of the results from this. So it's going to create another list object that I'm going to call temp peaks, and just keeping my numbers consistent. So I'm finding the peaks. It's analyzing this object, which we just created with CorMatch. That's pretty quick. It'll go through each one. And then here I want to see the results. So I'm just going to look at this object by just hitting enter. Cool. So it's showing me that it has, it's showing me this list object. Here's my survey file, and it's telling me how many templates there are. Here's information about the detections it made. This is the number of acoustic events, number of peaks for each template, number of detections. So there was 1 for my second template and 14 for the 7th one, which I'm not exactly sure what that is, but minimum peak score means the minimum correlation score for any acoustic event or peak, and so they're all pretty low. The maximum score, you can see for the ones that match, they're a little higher, and they're over 0.3, which was my cutoff. And then the minimum detection score is just the lowest correlation score for anything that was considered a detection or a match, so anything that was over 0.3. So you can see the lowest was 0.37, and in this case, the lowest was 0.3. And then the maximum of the maximum correlation score of detections. So the maximum of detections over 0.3, which was what I set my score cutoff to. So now that I've got this, I know there's some detections that I want to check to see if they're actually the Bonapartes or not. So first I need to set the wave player, which is going to play back my wave files. And I have a Mac, so it's been working pretty easily to use this AF Play as my wave player. If you have a Windows device or a PC Windows system, then you're going to need to use a different wave player. And there's been some issues with that, but it sometimes works if you just do the file path to Windows Media Player. But I'll have to do another tutorial or share information on that, because it gets kind of, it doesn't always work for everybody. And there's another wave player you can use that I haven't tested out yet, but somebody else may also be able to explain this really easily, better than I can. So there's set my wave player, and now I want to see results from, or I want to use show peaks, this function, to go through and verify all of the detections. So I'm going to need one of these for each of the templates. Okay, so I have 4 templates, so I'm going to create these list objects with show peaks, and I'm numbering them this way because it's matching where I'm at in my C scores. And this is 1 for the first template. And in show peaks, you'll need to keep this detection object matching the object here, the list object here. So that needs to be 187, 187, 187, 187. Okay. And then which one is specifying which template you want to use, and they're in order. So this is going to refer to CapCon Temp1 because it's the first one. And then this one, I'll want to change to 2, 3, and 4. Frequency limit, I do want to lower this because we're concerned about those lower ranges. So I'll just do 0 to 1. 0 to 1 kilohertz. Okay, so I'll go through this first. Actually, in our first one, we didn't have any detection, so I'm not going to check that one. CapCon 2 had 1 match, so I'll go ahead and run this. And then it's going to give me this display, which is showing a spectrogram from the range of 0 to 1 kilohertz, as I specified here. And it's putting a box around the spot that it's saying matched at, for this template, 0.37. And I want to listen to this. So when you run show peaks, it gives you this series of questions. True detection, enter Y for yes, N for no, NA for NA, P to play, R to rewind, or Q to exit. So I want to listen to this. So I'm going to hit P for play. And you might be able to just play out of your computer speakers. I use headphones because there's somebody mowing the lawn outside, but so I'll go ahead and play this. And I think that's Kinsey laughing, so that is not a Bonaparte's nightjar. So I'm gonna go ahead and put N for no. And then I want to listen to this fourth template because it had 14 matches. So it's going to take me through each one of these. This is also handy to look at ahead of time so you have an idea if you're going to search through 250 detections or something. It might take a while. So I'll do one of these and then I'll skip ahead for this video. So we'll search. Now I want to look at the fourth one and the results from that. This is pretty low. That's a no. It's picking up voices, so I'll pause here and then come back once I'm done going through these. So this last template, which was, I think, a test one from earlier, had 14 detections, but they weren't matches, they were voices in the similar range. So now I want to, the way I've been doing it for kind of a manual batch detection process is if there aren't any true detections that it comes up with, then I won't export a CSV just to save time. So in this case, it found detections that were false positives. So I'm gonna go ahead and skip to the next file that I want to survey. And so to do that, I can just go redo this with another file. And I'll need to skip ahead to the next actual survey, which is on the 24th. So I'll just go to the next number here. Now I want to survey the 24th. And that's same time, same templates. So it's searching with the function CorMatch. It's now searching this file for this batch of templates. And you can see it's going through each one, and then it'll let you know when it's done with one. It takes a few minutes. I think this one's taking like 3.5 minutes or something to do all 4 of these. Oh, and this is really common issue to have for me because I'm ignorant. So there's a way to fix this that I don't know yet. It'll run out of vector memory because you can specify how much vector memory is allocated, and I don't exactly understand what that means, but it's kind of like if it's only allowed to use a certain amount of the computer's memory at a time, I think. So for me, like every 3 searches or so, it comes up with this error message. And the way I've been dealing with it is just restarting R. I tried troubleshooting with, there's a process you can do to expand the vector memory of R, but when I tried that code, it wouldn't work for me. But I know there's a way you can expand your vector memory with a couple lines of code. I just haven't figured out how to get that to work yet. So if somebody else knows, that would be great to learn from someone how to do that, but I haven't got there yet. So I just save my file and then quit. And then restart R. Which is a really hack way to do this, but it until I figure out the code for expanding the vector memory, this is how I've been going with it. So what happened was for this process, it reached the limit. So I'm gonna redo that one. Oh, I forgot. So you restart R, you have to redo all of this upper part here, loading the packages and setting your working directory. But your templates are still there, so you don't have to redo that. You can see them there. It's still referencing the same one. So you just need to skip down to this Rightcore templates here. Cool. And then you can go ahead and continue where you left off with your line searching the file. So I've been doing this for like an entire species for all of the Binio devices, and just going through and numbering these as I go along. And this way I've been able to sort of manually go through a lot of files until I can get the batch CorMatch to work. Okay, so it's done with that. Oh, cool. So since I removed that other template I don't want to search for from the folder, it's now doing the 3 that I specified before. So it's all done, and this is this error message that is fine to continue past, but some people may want to try to troubleshoot this to keep the time source accurate, and I need to fix this at some point, but I can kind of work around it for now. So I want to see the results of this search, and so I'll just go through and match this number there. Okay, so it's done 1, 2, and 3, and then I'm gonna look at this list object, and there were no detections. So I'll go ahead and move on to the next survey file because that's been more streamlined for me. I don't need to print out this result. I'm just only going to go with when there's a match. So now I can go and just change this to the next time, since we know they all surveyed twice a day. So after the initial tests, you can just kind of go through and change the date and time as you go along. So I've gone along and I chose a test file where I know the Bonapartes is occurring, just to demo that. So I've searched this file for the Capcom temps, and then I've gone ahead and done find peaks, and then looked at that object here, and it's showing that it did find multiple detections for all 3 templates, including a couple that have pretty high correlation scores, so that's good, promising. I set my wave player, and then I'm going to go through these and listen and see if it is in fact. Oh, what did I do? Oh, whoops. Temp peaks test. Okay. Cool. So now I can go ahead and listen to these and verify if they are or are not Bonapartes. Yep. So that one is, and it has a really high correlation score. That last one did. This one's got a low score. It looks like it's the same thing. But so this is when I've set verify equals true in show peaks. But if you don't want to verify in R, you can just skip all of that and export your data table and then manually verify. But this is pretty convenient to sort of save the extra step of transferring to another way of listening. But anyway, so I'll go through all of these and then skip to the next part. So while I'm going through these, I'm on the second template, and I was curious if these would kind of double up on detections, and they did. There's a detection at this timestamp 138 seconds that both templates matched with. So if you are using multiple templates and they're not that different, you might end up with double results, which may not matter if you're just trying to see if the species is present or not, but it could matter if you're trying to count like total detections. So just a note about that. So I finished going through all of these and verifying which of the detections was true. And now I'm going to go on to getting that out into a CSV. And here's a note from Lauren Keeney. She explains this well here. And she's a research scientist who taught me how to do all of this. And she's using this same process to do species detection in her acoustic surveys too. So now we want to extract the detections from our object, our detection list object. So you use the @ symbol for this kind of object to extract something from that list. So I'm going to write test here because this is the list object that I want to extract the detections from. And so if we go back up or back to one of these list objects as an example, it has this column for detections. So what we're saying is we want to take this information out, I believe, with the @ symbol. And then sometimes you can have it do it for all of the templates. So that's why this one's named verified detect all, but you just give this list object a name that works for your workflow. Oh, and that worked. So it created this list here. Cool. And you can see the date and time is not accurate because it doesn't read the way the file name's written, or it doesn't read the date and time from our file naming system accurately. You have to specify a time zone and stuff. But anyways, so that worked. Okay, so now we have that list. And if you wanted to do each template individually, you then just use this, the $ to extract that specific template. But I've gotten them all with this one here. So now I want to turn it into a CSV. And here's another note from Lauren. So we're exporting the detections table, and you can export it as something other than a CSV if you prefer to. As she's saying here, you can do TXT, CSV, or Excel. Oh, and it's going to write your file into your directory, into this main working directory, unless you tell it to put it somewhere else. So the function is called write table. And I want to write this object that I just created or extracted, I guess, this object into a CSV file. And this is where I've been just using this name of the CSV file to track which file it came from and keep the date and time accurate. So in this case, it's from this file here. So I'll just match that. Okay. So it has the correct date and time. And then I'll name it Capcon temps. .csv, and then the separator is a comma, but if you were using a different format like txt or something, you might change that. Uh-oh. Okay, so I might have to go back and do individual. I don't know how to fix this yet, but you all might have some ideas. There is a way to fix this issue, but I'm too ignorant. So I'm going to go back and do each one of these and extract CSV files for each template. So we'll go back to Capcon temp 1. Okay. So I'm taking this template, Capcon 1, the information for that one. So in this one's for all of them, I'm going to just work with one of these at a time. So Capcon 1 here, which you extract from this bigger piece, which is this one with the money sign. And then I'm going to call that to match what it is, Capcon 1. I guess I can just call it Capcon 1. Okay, so now there's one of those. Oops, where'd it go? Okay, so it's showing the 2 detections. That's it right there, Capcon 1, and it's 2 detections. The date and time, which like I said is not accurate because there's no time zone information, and then the time that the detection occurred and its score. So I'll just do that for all 3 of these. Okay, So we got all of those, and now I want those to all become CSV files. So we'll go through each one again. Capcon 1 is the data table or list object that we want to, that has the detections for this template, Capcon 1, extracted from that list. And I want to write that into, I'm going to call it Capcon temp 1 or Capcon 1, so it matches which template it's referring to. And then I should see, yeah, so this file just appeared. It's a CSV file with that matching name. And then I'll go through each one of these and make CSV files for all of them. And then later I can just paste them all into an Excel sheet. So we'll do 2, change this to 2. And there's that file. And then 3. Cool. So if you want to look at this file, this is showing the data in it. This is for the third template, date, time, time, score. And then if I open that file, oh, here's one of them. This is Capcon 1, and this is the CSV file. There's the 2 detections. So I can import this into Excel, or you can end up exporting Excel files if that's preferable. And there's a way to get it to also extract your results from this verification process. So when you end up with a list of data, it'll include the results, like when you were selecting, yes, it's a true detection, no, it's not. You might be able to do it just by doing this. I'm not sure. Let's see what happens. That actually might extract only the true detections. So this is the CSV I came up with, which I think both of those were false positives. So I'll pause this and see if that's what happened with the one that has true positive. I tested this out to see if I could get the results of our verify, the process we used in show peaks, to show up, but this doesn't work, and I don't really understand which symbol I would need to use or how to do this yet. So, but it is possible, and if you're more familiar with R language, you could probably figure it out better than I can. But the whole point is that you verify it, and then you want to see those results as well, so you don't have to add them in again. So somewhere in this stage possibly is where you would be able to add that extra step. But then, yeah, you end up with these CSV files, which you can do what you like with. So that's a kind of run through again of how to use CorMatch and makeCorTemplate. And then, like I was saying, I have, let's say, like 100 survey files I want to go through. I just go through sequentially, and it crashes every few searches, so I just restart it. Or it doesn't crash, it runs out of vector memory. And that's how I've been working with this until I get batch CorMatch figured out, or some kind of loop code.